Hello everyone, welcome to ACE Maths. In today's video, we are going to solve 10 exam style questions on factorization. So this is the list of the 10 questions that we will be solving. Before I solve each question, I recommend that you pause the video and try to solve it on your own. If you haven't watched my factorization and HCF in algebra videos, I strongly recommend watching those first. I have linked them in the description. Let's solve the first question. Here we need to factorize 2p plus 4q plus 6r. So we need to find the HCF of 2p, 4q and 6r. First, let's start with the numbers. Here we have 2, 4 and 6. The HCF of 2, 4 and 6 is 2. And for the variables, we have P, Q and R. Since there are no common variables, no variable will be included in the HCF. So the HCF is simply 2. So now our HCF is 2, so we will factor out 2. Let me rewrite the expression 2p plus 4q plus 6r. So I will factor out 2 and here I will write 2p divided by 2 plus 4q divided by 2 plus 6r divided by 2. Alright? Now let's solve inside the bracket. Here we will have p, here we will have 2q, and this is 3r. So we have factorized the given expression and this would be the final answer. Moving on to the next question. Here we need to factorize 32p squared q minus 4pq squared. So let me find out the HCF of all the terms in the expression. We have 32p squared q and 4pq squared, right? Now, let's first look at the numbers. Here we have 32 and 4. The HCF of 32 and 4 is 4. And what about the letters or the variables? So here we need to take the common variables with the smaller power. That is how we find HCF. So here we have P and the smaller power is 1 from here. And for Q, we can write Q raised to the power of 1 because the smaller power of Q is 1. We can write it as 4pq. Now, since the HCF is 4pq, we will factor out 4pq. Let me rewrite the expression. We have 32p squared q minus 4pq squared, right? Now let's factor out 4pq. And if I factor out 4pq, then I will have to divide every term with 4pq, right? Minus 4pq squared divided by 4pq. Okay, now let's solve inside the bracket. Here we have 4pq. Okay, so now if you solve this, 32 over 4 is 8. P squared over p is p and q over q is 1. Here we will put the negative sign. 4 over 4 is 1. P over p is also 1. And q squared over q is q. Right? So this would be the final answer. Moving on to the third question. Here we need to factorize 1 over 2 into a plus 3 over 2 into b. Okay, let me first take the HCF of the terms of the expression. Here we have 1 over 2a and this is 3 over 2b. Alright. Now let's see how we can take the HCF here. For fractions, we need to take the HCF of the numerators. So here we have a and 3b as the numerators, and in the denominator I will take the LCM of the denominators. So I have 2 and 2. Alright. So the HCF of A and 3B, since nothing is common between the two terms, the HCF would be 1. And the LCM of 2 and 2 is 2. So we have found the HCF. Now let's factorize. We have half A plus 3 over 2B. Okay, and we will take 1 over 2 out, and here I need to divide 1 over 2a by 1 over 2, and here we will divide 3 over 2b by 1 over 2. Alright. Now if you simplify inside the bracket, this would be a and this would be 3b. Okay, so this would be the final answer. Moving on to the next question. Here we need to factorize 3 over 4 x raised to the power of 4 plus 7 over 8 x. First, we will find the HCF of all the terms in the expression. So I will write HCF of 3 over 4 x raised to the power of 4 and 7 over 8 x. Okay, so from the previous example, we already know how we can find the HCF of fractions. So in the numerator, I will write HCF of the numerators 3x raised to the power of 4 and 7x. And in the denominator, I will find the LCM of the denominators. So I will have 4 and 8. Okay. Now, the HCF of 3x raised to the power of 4 and 7x is x because the only common term is x. And for the LCM of 4 and 8, I can write 8. Okay, so we had x over 8 as the HCF. Now let's factorize. Here we have 3 over 4 x raised to the power of 4 plus 7 over 8 x. Okay, so we will factor out the HCF, that is x over 8, and now I need to divide every term of the expression with the HCF. So here I will write x over 8 plus 7 over 8 x over 8. Alright. Now let's simplify. I can write it as x over 8 outside, and here in the inside I will write 3 over 4 x raised to the power of 4 multiplied by 8 over x. You only need to multiply the inverse of the fraction present in the denominator. Similarly here, this would be 7 over 8x multiplied by 8 over x. Now let's simplify. Here I can write x over 8. Now let's simplify inside the bracket. 4 multiplied by 2 is 8. So clearly this would be 3 times 2 is 6. and x raised to the power of 4 divided by x is x cubed. 8 over 8 is 1, and I can also divide x over x is also 1. So here I will be left with 7, right? So this is the final answer. Moving on to the next question. Here, by looking at the brackets, one may think that it is already factorized. But if we inspect the expression inside the bracket, we will find that it is not completely factorized, and we can still factor some terms out. Okay, so let me first find the HCF of 3a squared and 4ab. Okay, so here the common variable is a, and we need to take the smallest power. So the smallest power is 1. So the SCF would be a. Now let's try to factorize the given expression. For that, we need to factor out the HCF. So here we have AB, and let me factor out A. Okay, so this A is the HCF that I am factoring out. Now, if I am factoring out A, then I should also divide each term with A. So here we have 4AB over A, right? Now, here outside the bracket, I can multiply AB times A is A squared B, and now let's simplify inside the bracket. 3A squared over A is simply 3A, and 4AB divided by A is 4B, so I can write minus 4B. Okay, and this would be the final answer. Now let's solve the sixth question. Here we need to factorize this given expression. Okay, so this is quite similar to the previous one because one may think that it is already factorized, but it is not. Let me show you how. First, find out the HCF of 15x and 5y. Okay, clearly the HCF of 15 and 5 is 5, and since there are no common variables, we can drop any variable from the answer. So the HCF is simply 5. Now let's go back to the original expression. We have 3 multiplied by 15x plus 5y, right? Now let's factor out 5. So we have 3, and if I factor out 5, then I will have to divide every term inside the bracket with 5. So here I have 5y over 5. Okay, 3 times 5 is 15, and now let's simplify inside the bracket. 15 over 5 is 3, so we have 3x plus 5y over 5 is simply y. So we have 15 multiplied by 3x plus y, and this is the final answer. Okay, now let's solve our seventh question. Here we need to factorize the given expression. So first let's find out the HCF of all the terms inside the bracket. We have 6xy and 10x cube y squared. So first let's look at the numbers. We have 6 and 10. The HCF of 6 and 10 is 2. So let me write 2 here. And now let's look at the variables. We have x and x cubed. So we will take x, and for y, we have y and y squared. We will take y because we need to take the common variables with the smaller power. So now we have the expression 2x squared y cubed multiplied by 6xy minus 10x cubed y squared. Okay, and I can factor out 2xy. So we have 2x squared y cubed, and now we will factor out this 2xy. Okay, so let me write 2xy. So when I factor out 2xy, I also need to divide every term inside the bracket with 2xy. That's what I did here, okay? So now let's multiply outside the bracket. I can write 2 times 2 is 4, x squared times x is x cubed, and y cubed times y is y raised to the power of 4. Okay, so now let's simplify inside the bracket. Here we have 6xy over 2xy. Okay, simply this is 3, right? And let me put a negative sign here. 10 over 2 is 5. X cubed over x is x squared. And y squared over y is simply y. Okay, so here we have 4x cubed y raised to the power of 4 multiplied by 3 minus 5x squared y, and this is our final answer. Moving on to the next question. Here we need to factorize ax minus by plus kax minus kby. If you look at the expression carefully, you will find that the variables x and y are present more than once. Okay, so we will start with collecting like terms. So let's collect like terms. Here we have ax and kax. These are the like terms, and here we have negative by and negative kby. So these are also like terms. So let's group the like terms together. We have ax plus kax and negative by and negative kby. Okay, so I have already grouped the like terms together. Now let's see how we can solve this. Here ax plus kax, these two terms are similar in the sense that I can factor out ax. Okay, so if I factor out ax, then I will have to divide every term with ax. So we have kax over ax. And you might be wondering, how did I figure out that I need to factor out ax? That is quite simple, and we have already done that before. For that, I just needed to find the HCF of ax and kax, all the terms in the expression. So the HCF of ax and kax is simply ax, and that is why I have factored out ax. Similarly, here we have by minus kby. Here I can factor out negative by. Okay, so if I factor out negative by, I will have to divide every term with negative by. Okay, so here we have negative kby, and let's divide it with negative by. Okay, so here we have ax, and inside ax over ax is 1, and here we have kax over ax, that is simply k, right? And what about here? Here we have negative by, and inside the bracket negative by over negative by is simply 1, and here negative kby over negative by. So if you divide negative sign with another negative sign, the result will be positive, and by times by is simply 1, so I will be left with k. Okay, so now look carefully here. Here I have 1 plus k, and here I also have 1 plus k. So I think you have guessed it correctly. I will now take 1 plus k as the common factor, and if I take 1 plus k as the common factor and divide the expression with the same 1 plus k, I will be left with ax and negative by. Okay, so 1 plus k multiplied by ax minus by would be the final answer. Moving on to the next question. Here we need to factorize 8ax plus 10ay plus 12bx plus 15by. Okay, very similar to the previous example. Here we also need to start with collecting the like terms, grouping the like terms together. Okay, so clearly 8ax and 12bx are the like terms, and 10ay plus 15by are also the like terms. Okay, so I will treat this as the first expression and this as the second expression. Okay, we find the HCF of 8ax and 12bx. So the HCF here is simply the HCF of 8 and 12 is simply 4, and here the common variable is x, so the HCF is 4x. Okay, and here for the second expression, the HCF of 10ay and 15by is simply 5y. You can check that out. Okay, now we have already found the HCF, so from the first expression I can factor out 4x. Okay, so if I factor out 4x, I will have to divide every term of the expression with 4x, and that is exactly what I am doing here. Now let's go to the second expression. So here I can factor out 5y, and for that I also need to divide every term with 5y. Okay, so now let's solve inside the bracket. 8ax over 4x is simply 2a, and here I will have 12 over 4 is 3, and here I will have b. Similarly, here I have 5y, and this would be 2a, and here I will have 15 over 5 is 3 and 3b. Okay, now look here, we have 2a plus 3b, and here also we have 2a plus 3b. So let's factor out 2a plus 3b. So if I factor out 2a plus 3b, I will have 4x, and here I will have 5y. Okay, so this here is our final answer. Let's solve the next question. Here we need to factorize x squared minus 2x minus y squared minus 2y. Okay, so first let's see what happens when we try to collect the x terms and the y terms together. So here we will have x squared minus 2x. Okay, all the x terms are together, and minus y squared minus 2y. Okay, all the y terms are also together. So now this x squared minus 2x can be treated as our first expression, and if I take a negative 1 as the common factor, I will have y squared plus 2y. Okay, so I can treat this one as the first expression and this one as the second expression. Okay, so clearly for the first expression I can factor out x. If I factor out x, I will have x minus 2 here, and for the second expression, if I factor out a y, then I will have y plus 2. Okay, so here you can see clearly that here I have x minus 2 and here I have y plus 2, no common factors. So we cannot proceed like this. Okay, so whenever grouping doesn't give matching brackets, try regrouping the middle terms. Okay, so first we tried to group x squared with 2x and it did not work. So now let's try to group x squared with y squared, negative y squared, and negative 2x with negative 2y. Let's see what happens. So I will write x squared minus y squared minus 2x minus 2. Okay, so we have x squared minus y squared. That is a very famous algebraic identity. It is x minus y times x plus y, right? And now here I can factor out negative 2. So if I factor out negative 2, I will have x plus y. Okay. Now look carefully. Here we have x plus y and here we also have x plus y. So we solved the problems that we were having before. We did not have any common factor here, but when we regrouped the terms, when we regrouped the middle terms, we have a common factor now. So let's factor out x plus y. So if you factor out x plus y, you will have x minus y here and minus 2 from here. So this would be the final answer. Well done for completing all 10 questions. If this video helped you, please like, share and subscribe to Ace Maths. You will find links to my HCF in Algebra and Factorisation videos in the description. Make sure you practice those too. In the next lesson, we will move on to solving linear equations. Thank you for learning with Ace Maths.